Welcome to Sundar's lecture. This is lecture number 95, and in this lecture we are going to see some numerical problems related to delta connection. Right? What are all the topics we have seen in the previous class? See, we have started with the line and phase currents and voltages in delta connection, and what we have concluded there, we have concluded that the line voltage and the phase voltage in a delta connected loads will be equal. Both are same. See, the line voltage will be whatever the voltage coming to this point, right? So this will be the line voltage, right, between these 2 points. These two are the points, right? So this is nothing but we are calling it as VRY, and between load, what is the voltage? Again the same 2 points are coming here, right? So we have concluded that the line voltage and phase voltages are equal, and then we have gone for the line currents and phase current equation, and we have derived this one. And what we have concluded at last, see, this is the conclusion we have got. That means this is the line current will be root 3 times the phase current, that means IRY, but lags the phase current by 30 degree. That is the point you have to be very carefully noted down. So that is what we have written here to see. We have just compared two different connections, that is star connection and the delta connection. In star connection, the line voltage we displayed by VRY, but in delta connection we would have denoted it by IR. See, this is line current here, but this is line voltage here. Try to understand, don't confuse yourself, because here I would have taken a different one, because that is the easy notation, so that we can easily understand. That is why I noted it like this. Anyhow, and now you see here, this is the line current, that is root 3 times the phase current, and this phase and this line current lags this phase current by 30 degree, right? That is why I have just written here as minus 30 degree, right? So now this is the given question, and you see the delta connected 3-phase load, that means R is 100 ohms, that is the given data. R is equal to 100 ohms, that is what they have given you, is connected to a balanced supply voltage of 100 volt. See, the voltage between these 2 points is 100 volt. That is what they have given you. Whatever the voltage they have given you, you have to take it as a line voltage, right? That is the base case we have seen also in the star connected load system, right? Then the phase sequence is RYB. See, simply it is RYB, and then considering the VRY as reference, calculate the phase and the line currents. That is the question. So what they have given you, the line voltage they have given you it as VRY, that is equal to 100 volt, right? That is equal to 100 volt, and see, VRY they are intimating here to take it as a reference. Then obviously what happens? So it will be 0 degree, right? We have to take like this. So since it is RYB sequence, what we have to do? Then VYB will be 100 at an angle of minus 120 degree, because the phase sequence is RYB. So R comes first, Y next, YB, and then VBR. What it will be? This is 100 at an angle of minus 240 degree, or we would have written it as a plus 120 degree. That is also possible, right? So now we have found all the values, right? We have found all the values. Now it is easy to find what is the value of IRY. What is the value of IRY? Which is nothing but it is VRY divided by resistance value. Why I am just taking? Because this is the phase current, and the phase current and phase voltages are equal. Try to understand. So I can substitute this value here. So what will be this value? You will get it as 100 at an angle of 0 degree divided by, what is the resistance value? It is also 100, right? It is also 100. So what is the value you will get? It will be 1 at an angle of 0 degree, right? It is 1 at an angle of 0 degree. So what will be this is RY and YB. See, do you need to really find the values again and again? No, it is not necessary. But if you know RY, then obviously it will be 1 at an angle of minus 120 degree. Amperes, maybe you put amperes everywhere. You just write the units so that it will help you. So it is 120 degree. and then if you are going for IBR, it will be again 1 at an angle of minus 240 degree, right? So very simple, very simple. Right? Now, what is the value of IR now? What will be the line current? This is phase currents. These are all phase currents, right? So what will be line current? See, this is IR, and whatever the current flowing here, it would have been, we would have written it as IRY. This current, it is IYB, and this current we would have written as IBR. Right, this is how we would have written the equation. So it is coming in and IB also coming in, this is going away, so it will be IRY minus IBR, right? This is the equation. We would have already written these kind of equations. So what you will get here, so IRY, it is 1 at an angle of 0 degree minus 1 at an angle of minus 240 degree, right? So if you further simplify this, I will get IR, just simplify, put it in the calculator, or you convert this into rectangular form, and then you just do the base mathematics, and you will get 1.732 at an angle of minus 30 degree. 1.732 at an angle of minus 30 degree. That is the value of IR. And if you know IR, then it is very easy, right? It is very easy. What will be IY? That will be also 1.732. This is minus 30 minus 120, what you will get? Minus 120, you will get minus 150. Very simple, right? Then if you go for IB, again it will be 1.732 at an angle of minus 240 from here, so it will be minus 270 degree. Try to understand. If you know one answer, then you can easily find the others too. See, it is also very simple to understand, but we have found like this, right? We have used a formula IRY minus IBR, then you simplify this and you are getting this. So no, it is not at all necessary to find an answer like this. Please try to understand what we have learnt here. See, try to understand. IR will be root 3 times IRY log by angle of minus 30 degree. Simple, simple, right? What you do? What you do? You just do this one. Since you know IRY, what will be IR? IR, it is root 3 times IRY. It is root 3 times IRY, and it will lags by 30 degree, minus 30 degree. So you put minus 30. What is the IRY value? It is 1, right? It is 1. So 1 into root 3, 1 into root 3, it will be 1.732. Very simple, right? 1.732, and it is 0 degree minus, if you put this one, so what you will get? It is minus 30 degree. Simply you got this answer, right? Simply you got this answer. Not necessary to write an expression like this and then you need to find the values of IR, IY, IB. No. That is why we have just taken these kind of equations, right? Try to understand. There are many ways to solve the problems, but you have to be very careful while solving the problems, because these kind of things will such a way it will help you in case of if you are going for competitive exams. It will be very helpful, right? Because you don't need to calculate these kind of things again and put the values, convert it into polar rectangular form, and then minus it, then convert it into polar form. It is very tough one, but if you do like this, then it will be very easy, right? So simply you can write now, if you know one value, very simply you can write 1.732 at an angle of minus 150 degree amperes, and then IB, it will be 1.732 at an angle of, from here it is minus 120 degrees, so it will be 270 degree amperes, right? So now we have found all the phase currents and line currents and also the phase and line voltages, right? Now we will move on to the next one. See, now this is the second problem. In the figure, the load is supplied from a three-phase balanced voltage source, and the phase sequence is ABC. They have given it as ABC, right? ABC or OB, anything it may be. If the current in the line A, that is line A, it is 10 at an angle of 0 degree, find the value of VAB. That is the question they have asked you. See, what they have given you, IA, that is the line current they have given you, that is nothing but it is 10 at an angle of 0 degree, right? Now they are asking you to find what is the voltage VAB, right? So if you want to find what is VAB, then what is the formula? You need to find what is IAB and divided by what is the z value here? Nothing but it is 18 minus j24, right? This value you need to find, right? Okay, fine, not divided by, maybe I made a mistake. Voltage you have to multiply, right? What is the formula for voltage? Voltage, it will be I into R, I into Z maybe, so it will be IAB multiplication of this Z value, maybe this is in between AB, right? So it will be 18 minus J24, right? Now we need to find what is the value of IB. Simply you can find the value of IAB. How will you find IAB? See, IAB will be is equal to, see, this is a phase current, right? What is the phase current? Maybe we know one formula, that is IL will be root 3 times I phase. I'm just writing it in a common way. That is the line current will lags the phase current by 30 degree. Now I need this one, phase current, right? This is phase current. What you will get? So IA, this is line current, divided by root 3. You take this to that side, and if it lacks the 30 degree, then if you are writing phase current, then it leads the 30. Then it will leads the line current by 30 degree. Simply you can put like this, right? So what will be the answer now? Now it will be 10 by root 3, 10 by root 3 at an angle of 30 degree, right? So what will you get for IAB now? So IAB, if you simplify this, IAB, if you simplify this, okay, fine, you keep this as now IAB, maybe I can directly substitute in the equation, I can directly substitute in this equation. So VAB will be is equal to, what is IAB here? It is 10 by root 3 at an angle of 30 degree multiplication of 18 minus J24, 18 minus J24. And if I finally simplify this, VAB, I am just getting, you just put it in the calculators, or you convert this into polar form and rectangular form, and I will get 173.2 at an angle of minus 23.13 degree volts. That's all. This is the value of VAB. Now what is VBC? What will be VBC? Just put minus 120 degree here, same value. VCA minus 240 degree from here, same magnitude value will get. But the question asked for us, it is only VAB. So we have found what is the value of VAB, right? This is the second question, and we will move on to the next one. See, now we need to go for the delta and y conversions. See, there is a common relation between delta and the star connection, and we try to find what is that relation. Maybe I will write it down the relation directly here. This is the relation. That means Z y connection will be is equal to Z delta connection divided by 3. This is the equation. This satisfies if all three impedances are same in delta and star connection. So we try to prove this one. So generally, see, we have a delta connection like this, right? This is the delta connection, and we know these kind of things, right? This is R phase, Y phase, and B phases are there. This one. So this is the maybe this is R phase, and this is Y phase, and this is B phase, and this value you just take it as ZY, maybe balanced load. If you take for balanced load, all the values will be ZY and ZY. So what will be the delta connection? So delta connection will be same, right? Whatever we have taken here, this is the delta connection. This is the delta connection maybe. These are all the three different connections, three different impedances, maybe loads, you can take like that. So this value, whatever it may be, right? So now if you take this as R, this as Y, and this as B, so we generally take this as delta connected impedances. This is delta connected impedances, right? Now what we try to do, one thing, we just try to get the value of this IA. Whatever we are getting here, it is IA, right? So maybe IR. in delta connection also the line current will be, we will take it as IR, right? And here too, for example, I am taking this to be IR. This is star connection. This is actually star connection, and this is the delta connection. We try to solve one equation, and we try to get what is the relation between, and we will finally conclude this equation will satisfy, right? And if you see what is the current here, it will be IRY, right? This is IRY, and whatever this current, it will be IYB, and what is this current, it will be IBR, right? We generally know this, and what we try to do here, we try to write what is the value of IR. What is the value of IR? We know, right? It is IRY. Now only we have just solved a problem, and we have written this equation. This is I into BR. We know these kind of things, right? So what we try to do, we try to get this equation in a way of writing this current in voltage and the impedance values. What you will get, it will be VRY minus VBR. Generally we write it as Z delta. Why? Because both the divisions will be same, right? It will be Z delta. And what is the value of VRY? Try to understand. I'm just writing the expression for IR. What is the value of VRY? We also know that, right? What is the value of VRY? It is VR minus VY. We know this one. This is what we have seen in the star connected systems, right? Then minus, put minus, then what is VBR? It is VB minus VR. It is VB minus VR whole divided by Z delta, right? So if you further simplify this, just getting into this one, if you put minus, it will become plus, right? So what I am getting here, 2 VR, that will come down, and then I will have minus Vy minus Vb the whole divided by Z delta, right? I have written the equation like this. Maybe what I will do now, I will add a value here. Maybe I will add a value here as VR, extra 1 VR. What I am just trying to tell you, I just add a minus VR here and put 3 VR. Maybe that equation will satisfy, right? So what I will do, I will just write it as 3 VR minus VR minus VR minus Vy minus Vb. This equation will satisfy. If you simplify this, you will get this one. Anyhow, so I can write it as minus 3 VR minus of, I can write it as VR plus Vy plus Vb, right? Whole divided by Z delta. Try to understand what is this value. What is this value? VR plus Vy plus Vb. Obviously, it will be 0, right? We have seen these kind of things, right? You just refer my first lecture. We would have done this one, right? This value will become what? It will become 0. Simply, it will become 0, right? What I will get right now, IR will be is equal to 3 VR divided by Z delta. Or in another hand, I can write IR will be is equal to VR divided by Z delta divided by 3. Right, like this. Maybe I will take this as number equation 1. Right, now what I will do, I will just write the expression for delta connection, star connection. This is for delta I have written. This is for delta I have written, right? So now if I want to write for the star, for star, if I write for star connection, it is very simple, right? What will be the equation for star connection? What is IR value? What is IR? This IR, very simple, right? It is EZY by it is VA. This is the phase voltage or line voltage. Both are same. Sorry, not line voltage. Maybe the phase and line currents are same. So what I can write here, IR can be directly written as VR divided by EZY. Simple, right? Because this current and this the line current and the phase current will be equal. So I can write like this. So now I will write this equation as number 2. Just compare 1 and 2. just compare 1 and 2, simply compare, maybe I will put it here, compare 1 and 2, compare 1 and 2, what is the final expression you are getting? See, both are same, both are line currents, and in line currents, what is the impedance value you are getting? It is EZY will be is equal to EZ delta divided by 3. Always you try to understand, if you want to remember this equation, you can simply remember this equation. Always star connection impedance will be lesser than the delta connected impedances. That is the application of these kind of things. It will come under the three-phase motors. Always they will start with the star connection and then they will go for a delta connection. So many things are there. Star delta, status, application of star delta, status. They everything will come under these kind of basis. Okay, fine. Anyhow, the star connected impedances will be is equal to delta connected impedances by 3. Our delta connected impedances are 3 times star connected impedances. If both values are same. If I want to convert this star into delta, then what I have to do? I have to just multiply all the values by 3 times. Simply, right? Maybe we will take an example. Right now you just see, we have taken on one example. We try to just convert this delta into star connect equivalent impedances, right? We need to find what is VABC. This is the same problem we have taken here. Whatever we have taken in this one, this is the same problem, right? Try to understand the same problem I have just taken here. And what is the VAB we got there? VAB, what is the VAB we got? VAB will be is equal to 173.2 at an angle of minus 23.13 degree volt. This is what we have got, the same problem I have taken here. So now we need to find what is the value of VAB using this one. Now what is the equation we know? EZY will be is equal to EZ delta divided by 3. 3 times we need to divide this delta to get a equivalent star, right? So what will be this value? Maybe it is 18 minus J24. So if you divide this by 3 times, what you will get? It will be 6 minus 4 times, right? 6 minus 3, right? 3. If you divide it by 3, it will be 6. If you divide it by 3, it will be 8, right? So it will be 8J, 6 minus 8J, and this will be 6 minus 8J. And we need to find ohms, maybe ohms. And we need to find what is the value of VAB, VAN, right? So that is what we need to find. So now we have to we need to find what is the value of VAB, right? So how will you find VAB? It is very simple, right? It is we can write it as VA minus VB, right? So if you go in this way, maybe we would have already written these kind of equations. That is nothing but it is VA minus VB. It is very simple, right? So how will you find VA? VA will be is equal to, maybe that is nothing but the phase voltage. So how will you find the phase voltage? what is the line current it is coming here? That is nothing but it is 10 at an angle of 0 degree, right? That is what they have given you. So now it is very simple. Whatever the current it is coming here, also, that is also same here, right? Line current and phase currents are equal in the star connection. So current value multiplication of whatever the impedance you have here, it is 6 minus 8J. So simply I can find what is the value of VA. So if you simplify this, I am just getting it as 100 at an angle of minus 53.13 degree volt. Right now it is very simple. If you want to find what is VB, very simple. How will you find VB? From here it is minus 120 degree, right? So it will be minus 120, means it will be 173.13 degree volt, right? So now we found what is the value of VA and VB. You just substitute in this expression now. So VAB will be is equal to 100 at an angle of 53.13 degree minus 100 at an angle of minus 173.13 degree. So finally, if you simplify these two equations, so VAB will be is equal to 173.2 at an angle of minus 23.13 degree volts. Try to understand these kind of things. Is very important to understand these kind of basic things, right? So you just convert this into a rectangular form, and then you just find what is the value, and then you convert that into polar form again. So see here, we are getting the same answers, right? See what we have done here, we have just converted this delta connected impedances into equivalent star connected impedances, very simply, right? So now this is the formula, and now this is satisfying. Both VAB are same here. Whatever we have between the two lines, we are getting the same voltages. Try to understand, right? So this is the proof, whatever we have derived in the uh, star delta equivalence or conversion. This equation will always satisfy, right? What are the topics we have seen today? We have taken two problems. We have solved two different problems in the delta connected loads with the expressions what we have derived in the previous class, and then we have gone to star and delta conversions or star delta equivalence, and we have just derived an expression that is star impedance will be is equal to delta impedance divided by 3 times, or you in other hand the delta impedance will be equal to 3 times the star impedances. And we have taken a problem and just we have converted the delta connected impedance into star equivalent star connected impedances, and we try to find what is the voltage between the A and B phase, and we are getting the same answers, right? So up to this we have just concluded what is star and delta connection, and in the next class we will see a new topic. Thank you.